All right, so let's do this example. What we're going to do is basically we have a steam and it's living a 4-liter pressure cooker whose operating condition is 150 kilopascal. So the pressure inside this pressure cooker is 150 kilopascal, and it is observed that the amount of liquid in the cooker has decreased by 0.6 liter in 40 minutes. So 0.6 liter have left basically the pressure cooker as steam in 40 minutes after the steady operation condition are established, and the cross-sectional area of the exit opening is 8 millimeters squared. Okay, so we have the cross-sectional area as well, and we want to find the mass flow rate of the steam and the exit velocity, right? So well, it's a constant pressure, right? And we want to find the velocity, flow rate, total flow energies, and rate of energy transfer by mass, right? So the flow is steady, and that's what the problem is mentioning, right? And it's basically a two-phase equilibrium inside your pressure cooker. And what we can do in order to get some of the properties, it's basically it's water, right? So it's a liquid water, right? And how to find that? So if we have a two-phase basically condition, which table should we refer to? Do you remember from previous chapters? So it's a saturated vapor liquid mixture, and that's water, right? And we do have the pressure, which means that at P equal to 150 kilopascal, we need to go to table A5, right? And that's based on the pressure, and we can get some information about the fluid. So I'm going to show you how we do that. So this is basically table A5, right? And the pressure is 150 kilopascal, so it's here, right? That's our pressure, and we can read the liquid specific volume, gas specific volume, internal energy, both basically for liquid and vapor, and also the enthalpies for liquid and vapor, right? So that's table A5, saturated liquid vapor at 150 kilopascal, and we basically write this information down, right? So what is leaving? It's basically your vapor basically is leaving your system, right? It doesn't leave as liquid, but it does leave as a vapor. So all right, but I'm gonna write all the information we have. So nu F is 0.001053 kilogram per cubic meter per kilogram. Nu G is equal to 1.1594 cubic meter per kilogram, and Ug is equal to 2519.2 kilojoule per kilogram, and that's Ug, and then we have basically Hg, right? That's the enthalpy, which is 2693.1 kilojoule per kilogram. So we have all this information about our fluid, right? And when basically our system, so the first thing we want to calculate is the mass flow rate. So how to find how much mass have left our system? That's the first question you need to ask yourself, okay? So the mass, we have some information about how much volume of basically vapor have left. That's 0.6 liters, right? So if we have how much volume of liquid have left our system, and if we divide it by a specific volume of the liquid that is left, we can find the mass of the liquid that have left our system, right? Because this is in the specific volume is in cubic meter per kilogram, this is in cubic meter, the result is kilogram, right? So we have 0.6 liter have left our system. The specific volume of liquid is 0.001053 cubic meter per kilogram, and we need to convert liter to cubic meter. The result is 0.57 kilograms. Okay, now it's easy to do that. M dot is equal to M divided by delta T. So mass is basically 0.57 divided by 40 minutes, and that is equal to 0.0142 kilogram per minute. Okay, so that's our mass flow rate, which we can write it in terms of kilogram per second as well. So 2.37 10 to the negative 4 kilogram per second. How about the velocity at the exit? So velocity, remember the relationship between velocity and mass flow rate. We don't have density, but we do have the specific volume of gas that is leaving our system, right? So that's equal to m dot specific volume, because density is equal to 1 over nu, remember that, divided by cross-sectional area. M dot is 2.37 10 to the negative 4. Nu g is equal to 1.1594 cubic meter per kilogram divided by 8 multiplied by 10 to the negative 6 meter squared. That's the cross-sectional area. Results in 34.3 meter per second. All right. So please note, when we wanted to calculate the mass, we use nu f. When we want to calculate the velocity, we use nu g. The reason was that we know that basically 0.6 liter of the liquid is vaporized. So here, when we want to calculate the mass, we have to use how much liquid, basically the specific volume of liquid. However, when we want to calculate the velocity, the fluid that is leaving our system is vapor. So you need to make sure you use basically nu g in your calculations. All right. So that's basically part A. So I'm gonna basically erase all these so I can write again. All right, so the next part, what we're gonna do is to calculate the total energy of flow, right? And also we need to find the that's it, right? The total and flow energies. So the total energy is basically theta, right? Theta is equal to, this is a flowing fluid, right? Is equal to enthalpy plus kinetic energy plus potential energy. And we can ignore the potential energy, the kinetic energy, and the enthalpy is going to be equal to, we already have the number, right? 2693.1 kilojoule per kilogram. As easy as that, okay? And the flow energy, remember, was equal to P pressure multiplied by specific volume, which is H minus U, right? Remember the relationship between enthalpy, internal energy, and specific, the flow energy, right? So H is equal to 2693.1 minus 2519.2. That is equal to 173.9 kilojoule per kilogram, right? And that's it. That's part B. Okay. So this is part B. Part C is the rate of which energy leaves the system. That's pretty easy as well. So we need to calculate the E dot mass by using the relationships m dot multiplied by theta. M dot was equal to 2.37 10 negative 4 kilogram per second from previous part A, basically, multiplied by 2693.1. We found it from basically the enthalpy in part B. and multiplication of these two results in 0.638 kilojoules per second, or 0.638 kilowatts. Okay. All right. So please let me know if you have any questions, and make sure to attend the office hours.